Okay, today we are going to try to find a formula for Sierpinski's triangle for the showing the perimeter. And also I will be demonstrating several steps that I took to create this formula. We start with an equilateral triangle. For the sake of simplicity, we're making them 1 unit in length, and by taking the perimeter, we will select the highlighted segments here, and these highlighted segments will show that 1 plus 1 plus 1 equals 3, and this is how we find the perimeter for the first triangle. Okay, now for piece of 2, we have we take the midpoint of our equilateral triangle, which is again 1 unit in length, and the triangle that is represented in cyan is half the size of our original equilateral triangle. Now when we select the highlighted line segments, we'll get the perimeter of this triangle, piece of 2. We have 3, which is from the first equilateral triangle, plus 0.5, which is our length of our new triangle, and there are 3 line segments to that length, which then gets a total perimeter of our piece of 2 as 4.5 units. Now for piece of 3, we will now go and take the midpoints of where our original equilateral triangle is represented in white, which now we get 3 green colored equilateral triangles, which are half the size of our cyan triangle. And by taking the areas of these ones, we have piece of 3, which will be again our highlighted line segments, which are shown here. Piece of 3 is again piece of 1 plus piece of 2 plus 9 times 0.25. 0.25, we get that from our midpoints of our line segments, and there are 9 line segments total for the green equilateral triangle, and that gives us a distance for perimeter of 6.75. Okay, for piece of 4, the same rules apply for exactly the same as piece of 1 and piece of 2 and piece of 3, where we take the midpoints of the white space surfaces of our original equilateral triangle, and we get 9 red equilateral triangles. And now we have to find the perimeter of all of our line segments. There, for piece of 4, we get again piece of 1 plus piece of 2 plus piece of 3 plus, now we have 27 times 0.125. And just like from our previous steps before, we get our line segments highlighted. 0.125 is the distance of our new lengths of our equilateral triangle represented in red, and there are 27 total line segments for the red surface, which comes out at 10.125 units. And now my last example, piece of 5, is again our same equilateral triangle, making the midpoints of all of the white surfaces, which now we get blue equilateral triangles. There are 27 of them total, And again, to find the perimeter of piece of 5, we get piece of 1 plus piece of 2 plus piece of 3 plus piece of 4 plus 81 times 0.0625. Just like our other steps, 0.0625 is the length of our triangle segments, and there are 81 line segments that are represented in the new equilateral triangle. By adding all these together, we get 15.1875 units. After giving several examples, it's time to find a formula for the perimeter of Sierpinski's triangle. So, for example, say you want to find the perimeter of piece of 10 or piece of 100 or piece of 1,000 or even a million. You can use a formula instead of going through finding midpoints of triangles, and that can be kind of tedious. And so the formula I came up with was piece of n equals, in sigma notation where n equals 1 and it goes to infinity, is 3 times 3 over 2 to the n minus 1 power. The great thing about that is it works. So for example, say we check piece of 1 where n equals 1. 1 minus 1 is 0, and 3 over 2 to the 0 power ends up being 1, and 3 times 1 is, you guessed it, 3. And if we do one step further, piece of 2 where n equals 2, 2 minus 1 ends up being 1, so 3 over 2 to the 1 power is 3 over 2. 3 divided by 2 times 3 is evidently 4.5. And as we keep getting larger and larger numbers of n, we end up getting larger and larger perimeters. As we go to infinity, we find out that it has an infinite measure, where you always can find the midpoint of another triangle in that white surface that's represented by our original equilateral triangle. So that is the formula for Sierpinski's triangle for its perimeter. Thank you.